Hi, my name is Bob Grenier, and I'm a volunteer with the Martin Fleischmann Memorial Project. So, welcome this 24th of November, 24, to O-Day. Infinite potential. How is everyone? Can everyone hear me? Athena Beck, DIY Projects with Chauxus, Tammy Nicknock, Ken Pratt, Vanilla Isis, hi Gebs, new one in the house, HR Misunderstood, Yin Gazda, hi Denza, sorry, I can't really understand your handle there. Hi Earthworm Jim, thank you for your AI work there, that's great. Hi Stephen B. Halls. Hi Technology Envoy, Venom K, Alex Looseman. It's great to have you all here. And hi Gordon Doherty. Wonderful. Hi Mickey Avila, CBK Wahoo, and Rene van der Woude. Sorry if I get your name wrong and misunderstood. There we go. Mark Alexander. How is everyone today? Can you hear me clearly? If so, then I shall begin. How is everyone? Great. So, what you're looking at on the screen there is a little AI-generated image that I worked on a little bit this afternoon. And I quite like the way it came out because it has these toroidal impression marks on like the window that's in front of the girl that's looking through. And there's going to be a lot of potential with what is to come, but there is also going to be some risks. And one of the risks that we need to deal with is the radiation that comes out of these structures. And you will see that these toroidal type of impressions here on the glass are quite similar to those that I have witnessed. In fact, the background of my desktop here are these kind of toroidal marks that I captured, imaged on the fused quartz anode sheath of Henk Urian's Vega experiment. And if you recall, we had this toroidal plasma in what he calls a hot tube, and it has this umbilical vortex going into it, and periodically it destabilizes and it launches itself off at great speed and collides with the fused quartz on its way to try to get to the anode because of the potential. And it leaves these various marks, so I thought it was quite appropriate to have these on this image here. MF Lauder says, magic donuts of God. Something similar to that, yes. Very good. Now, of course, these things have been around for time eternal. However, one of the more recent investigators of these things was one Ken Shoulders. And thank you to Carmen Miller for sending me this now to be famous letter. Thank you, Gary Johnson. Very much appreciated. This is on California Institute of Technology paper, the Charles C. Luratine Laboratory of High Energy Physics, January 31st, 1986. And it's addressed to Dr. Kenneth Radford Shoulders, Institute for Advanced Studies. And this, of course, is when he was working with one Hal Puthoff here on the study of John Hutchison's work and of what he was to eventually call exotic vacuum objects. So I'm going to go to a little bit of a blow up here so we can see this in a little bit more clarity. Dear Dr. Shoulders, when you were in my office, I could not see how 10 to the 10 or even 10 to 11 electrons could be kept as a ball in a vacuum without ions. So I was skeptical and didn't let you tell me about them. I must apologize, for it has come to my attention that it is indeed possible. In a uniform magnetic field, a group of electrons rotating at the Lama precession frequency, omega equals EB over LM, I might be reading that wrong, but anyway, feel, from the point of view of an observer rotating with them, a force toward the axis, which would in size be equal to the centrifugal force expected from this rotation, but directed inwards. Then an electric quadrupole could be used to hold them by repulsion along the x-axis, as long as the force away from the axis generated by the quadrupole does not exceed the previously noted confining force from the magnetic field. By adjustment of the size of the quadrupole field, the forces of confinement can be made equal in all directions, just as if there were a density of ions in a vacuum, and a rotating sphere of charge is possible. The size seems to be governed by the electric field available without breakdown, but it looks like a reasonable possibility is 2 × 10⁻11 electrons in a magnetic field of several hundred Gauss. Now that I understand how it might work, I should be glad to discuss it again anytime you wish. My informant was the physicist Curtis Mitchell, who told me that ions were confined this way at the Bureau of Standards. Ions are easier. The electric field needed is less, and B can be raised to, say, 15,000 Gauss. Some work of this kind was started 10 years ago at UCSD by Professor M. I forgot the full name, but at first the phenomena seen were not understood. I again apologize for my skepticism, which prevented me from hearing about something very interesting. Sincerely, Richard P. Feynman. You know, when you realize you might have got something wrong, it's always good to eat a bit of humble pie and apologize. Well, that's at least what I think. So that is the full letter, and thanks again for Carmen, who is in the house. Thank you very much for getting that to me. If you'd like to credit the person that gave it to you, if they wish, then that's good too. Okay. Now, we're going to look at a paper that I've actually looked at before. We're going to look at it in a little bit more detail because we understand more. Then we're going to look at a few other papers, and then we're going to look at some information that was released today, and we're going to have a practical experiment interlude. What I can say is we really are on the dawn of a old age. And both propulsion and unlimited energy, the likes of which has not been seen in probably 12,000 years outside of black projects, is upon us. And we're going to have to grow up, people. From my point of view, as I've said recently, this gives us the golden opportunity to clean up our waste as it's produced. So with unlimited energy, you get the possibility to have very, very, very clean environments, and no excuse for not doing that, because it really comes down to the cost of cleaning things, and cleaning costs are generally down to the energy that is put in at some point of the equation. So with unlimited energy, we should have a very, very clean environment. And happy days ahead. So back to my start image. First off, I think. Yeah, and I'm talking about these impact marks here because there is something that needs to be resolved with this technology. I have been focusing on it for about 5 years, and I think we have a solution, and it needs to be tested in the presence of functioning devices. And so let's have a look at a couple of examples of that. The impact marks over and above what I have shown you a little while ago. So where are we? Give me a second. Here we go. So it's from my remote view blog post, the mark of an exotic vacuum object. And you can go and see various examples, but I have this whole sequence of images here, and you can go and download the original files and more of them that are shared on here at this link here, but I have them here. So you can see this whole image here, and we can go into individual ones here, zooming in, and you can see something in the center, and then a lot on the outside. And in this case, you can see it's roughly, what should we say, 1, 2, 3, 4, 5, 6, something like that. But you can see it's almost a ball made of balls. It seems to have these spheres around it. But again, it's got something in the center. This one looks a little bit square. This also looks square. We can zoom down here. 1, 2, 3, 4, 5, 6. Less defined on the boundary here. Here's a very, very large one. And you can see it's got a very untouched area in the center. And this would imply that this has to be a torus, so there's nothing to be affected in the center. Or it's a spindle torus, such that the boundary is not touching the fused quartz and interacting with it here. So again, here's another one. There's another one. There's plenty of them, different scales. This one. 1, 2, 3, 4, 5. Definitely sort of 5 around there. Again, 1, 2, 3, 4, 5. This one's got 4. So that's that one. Here's another one you can see. It's a little bit not so long here. Very clear here. Now it could be that these are largely spherical or almost geodesic, buckyball-like shapes. And what you're seeing is that the interaction of more of the substructures that are bound onto the outside, or the outside structure itself. And it's kind of like a Fresnel effect. You've only got one skin deep here, but you've maybe got quite a bit interacting at this point. There's 2 very clear here. This one's slightly distorted. It might have come in and crashed at an angle. Very indistinct one here. Some here. These are out of focus. A selection of them here. This one looks like it crashed in, but it kind of had like a whip arm to it. Some very clear small ones here. Very clear ones. There's a very clear pentagonal one, but quite small. 1, 2, 3, 4, 5, 6. But this is like a truncated triangle. 1, 2, 3, 4, 5. This is 1, 2, 3, 4. This looks like an 8. 1, 2, 3, 4, 5, 6, 7. Well, 7. I think we found a 7. Have we found a 7? If so, that's the first 7 that I remember finding. I like this one. It's 3. Triangle there. 1, 2, 3. Just 3. Here's a squarish one. 1, 2, 3, 4. This is one that's hit on the side. A very important one. The reason this goes out of focus is this is a cylindrical piece of fused quartz. And so as the vortex is expanding out, it's actually interacting less with the material as it's sloping away from it. But, let's go back there. This is the in vortex and then the out vortex, and this is, you know, one side of the toroidal structure, and this is the other side of the toroidal structure, and this is the caduceus beam coming in. Okay, and you can see it goes off at an angle. Sometimes you can really clear that you see the substructures around it here. Whole bunch of them here. I think we got one more. No, we haven't. Okay. Now, I've referred to this CIA report a number of times. It's on my Steemit. I remastered the document. CIA report from the 16th of June, 1992. Russian document claiming a new phase of matter. So if you recall me, I shared and translated this video by Ed Lewis, and he's suggesting that a plasma toroid, abbreviated to plasmoid, is in fact a new phase of matter. And this is something that was claimed by these Russian researchers in 1992, suggesting that 1 kilogram of iron is sufficient for an interstellar journey. That is, the energy contained within 1 kilo of iron, the hidden energy within there, can yield that amount of energy. And down here, they are implying that it is the same process as cold fusion. So when they're asking what the form of the energy is, whether it is nuclear or fusion reactor in the space vehicle, he says neither one of the three, or is perpetual motion nuclear or fusion reactor. He says neither one of the three. Vasily Dmitrievich responds, do you recall another sensation which was trumpeted roughly at the same time as high temperature superconductivity? It was reported that the so-called cold fusion was discovered in the United States. Then this phenomena was replicated in many laboratories throughout the world. That is, it was replicated yet again, could not be explained. And why? Simply because they were trying to find the features of fusion reactors where they couldn't be found. And the guy goes, I remember those experiments vividly. I even observed one of those at Moscow State University. A jar with heavy water, 2 live electrodes, and all of a sudden additional heat, as if from nowhere. And if its source is not cold fusion, then what is it? Well, we call this phenomena energy conversion. And the jar itself is a primitive converter model. Water boils in it. Using the scientific language, we are dealing with a phase transition. Yet in this case, the water particles are moving in an orderly fashion due to an electric field. And in such cases, according to our theory, phase transitions result in an increase in energy release. And this is what I was talking about, where you are condensing from a more rarefied form of matter to a more dense matter, that is condensation, and you release energy. So to their theory, when you have a phase transition, say from plasma to gas and gas to liquid, liquid to solid, and this transition to a new type of phase of matter, you get an increase in energy release. The gain is sometimes 2.12 to 4.2 times greater than the work spent. Wait a second, I'm trying to interrupt what I've just heard. Are you talking about perpetual motion? No, we are talking about extracting the inner energy of the matter. And can it be used in any way? Be my guest. You can even design power plants instead of the traditional ones. Yet I must repeat that it would be extremely primitive when boiling water. And of course, such a converter is not suitable for space flights. They extract energy, this is my commentary here, from metal and directly generate electricity, which enables them to close the loop, yielding effectively a COP approaching infinity until all the fuel is in the new phase. Okay? So this is essentially what I'm saying. If you have anything over 1 and the system that captures that power out as electricity, then can drive the system using electrical power. As long as the losses are less than the COP, then you effectively have infinite COP. So when you've exceeded the losses in the driving system, any COP over and above that is not really that relevant. Okay. So we have already found an electrical analog of the process during which conversion occurs, Shibitnik continues. And it can be extracted not from water, but from, say, metal. Suppose you plug our converter into an electric generator. So on the output, you produce 4 times as much energy as it can generate operating in a traditional fashion. You use 1/4 of that for generator power supply, and the remainder is available you as a gift from the microcosm. This means, this is my commentary, this means to convert the metal to this new phase, releasing energy, includes an electron accelerator, which also enables propulsion, which makes it sound a lot like Kenneth Scholder's early 1980s or Chernetsky's 1970s technology. Okay, they go on. Yet in reality, of course, everything is a lot more complicated. In essence, the energy converter consists of several simultaneously operating devices. Its principal elements are closed superconductor and a control system. A closed superconductor. Now, if you have electrons and they are coherent and they become superconducting and they are in a toroid, then you have a closed superconductor and a control system for it. This is for terrestrial needs, but the electron accelerator connected to the circuit turns the converter into a space propulsor. So the same thing that is allowing the acceleration of these electrons converts the whole system into a propulsion system. And they are saying here that using it, one can reach Alpha Centaurus and return back in 12 years. And I think that works out at about 0.8 of the speed of light if you've got acceleration and deceleration times. Have you been able to replicate these processes, at least experimentally? Yes, otherwise I wouldn't be telling you anything. In our estimates, the energy concealed in 1 kilogram of iron is quite sufficient for an interstellar journey. Well, the outlook is quite fantastic, even without flying to other worlds. After all, the energy converters will be quite suitable for earthly needs. It's about time to start dreaming not only about miracle generators capable of replacing nightmarish nuclear and fossil fuel power plants, but also a new means of conveyance. All of our lives could be changed dramatically. What if I told you that had already been done? I think it had been done about 50, 60 years ago. I had more corroboration of that in the last couple of days, and I had a lot more corroboration on the energy converter, and I believe that what we saw that I shared in this paper here, or presentation Ode Galactica, which was this. This is the 1979 field resonance propulsion concept to the US Department of Commerce National Technical Information Service for the NASA, National Aeronautics and Space Administration. Okay, and it was from June 1979 that was originally thought up, June the 18th to the 20th. And the means by which it is achieved is by this structure, which has a current loop, current loop, current loop, current loop, current loop, current loop. These produce magnetic fields which connect within the center, and because of the way they connect, they end up with a torsional magnetic field in the center, and this produces a phase singularity. The phase singularity and the toroidal moment is absolutely critical to how this process works, and I'm going to show you 2 papers that makes this abundantly clear. Okay, first up, a quick look at this paper. This is Theory and Applications of Toroidal Moments in Electrodynamics, Their Emergence, Characteristics, and Technological Relevance. This is from Nanophotonics in 2017, mainstream journal. And here they show that these structures both have a toroidal moment. And in fact, what you're looking at here is what's called a horn torus. It actually looks like a sphere, but effectively it is a torus. And the electrodynamics inside end up by producing a sphere on the outside. And this again is a torus. So these are both two forms of tori, and both have poloidal, as it says here, current density and magnetic moment distributions associated with the toroidal moment. Poloidal currents excited at the surface of A, poloidal currents going through the center, and B, a toroid. So these are the poloidal currents. So this is a current loop, and this is a current loop that then goes through the center, current loop that goes through the center. Equivalently, a ring of magnetic moments is also attributed to the excitation of the toroidal moment. So we have the magnetic moments in a ring producing the toroidal moment, and these are poloidal electric currents. Okay, so that is one image. So both Ken Shoulders and Takaaki Matsumoto observed that these structures can form into spheres and toroids. Spheres and toroids. But the reality is the sphere itself is actually a torus. Okay? Right. So I am going to now look at a paper that was part of the University of Dayton Research Institute, and I talked about it before. As I said, it's unclassified. It's called force-free time harmonic plasmoids, plasmatoroids. Okay, and it's by Jack Nachamkin and University of Dayton Research Institute, Dayton, Ohio. And here we can have a look at this. It's Phillips Laboratory, Propulsion Directorate. Phillips Laboratory, Propulsion Directorate. Are we getting the picture here? Air Force Material Command at Edwards Air Force Base, California. Now, as I said recently, I was informed, although I haven't been able to verify it, but maybe someone in the US can do a freedom of information on Edwards Air Force Base. There was a Ken Shoulders type device that produced far more electricity out than in. Okay. So I'm just going to go through, I've pointed out a whole bunch of stuff in here. So I'm just going to click, I've got these links here. I will share this, but just to show you the date here, this is October 1992. Okay, that was the report date, and the interim report was on November 91. Okay, to July 92. Okay, Edwards Air Force Base, California. Yeah, Frank, you saw Frank Mead. Well, there we go. I'm going to click on this thing here, pointing vector. Is that the first thing? Yeah, okay. We'll go through this in time. Okay, so a heretofore unexplored solution of Maxwell equations is investigated for time harmonic waves in a partially ionized gas. Resonant sizes will be shown to exist such that plasmoid will not exchange energy with their external surroundings. That'll be a non-radiating barrier, and their boundary conditions can be met by vacuum solutions to Maxwell's equations. You can read this in your own time. I will share the link again. The research was spurred by attempts to understand experimental results obtained in the late 1960s and early 1970s in areas of fusion weapons and laser fusion in Los Alamos. So, this is for the, let's just go over that again. It's for the Propulsion Directorate. The Propulsion Directorate. They are investigating whatever the structures are that they think are plasmoids. And it was, this particular research was spurred by attempts to understand experimental results obtained in the late 1960s and early 1970s in area of fusion weapons and laser fusion research. So, in the period of close to 2 decades after performing the original work, some of the insights gained into solutions of Maxwell's equations in a conducting fluid were seen to have relevance beyond controlled fusion community. In particular, finite-sized, non-plane wave, force-free time harmonic electromagnetic excitations with electric and magnetic field vectors parallel to each other everywhere in the presence of plasma current seem to be undiscovered solutions that deserved exploration. So time harmonic is basically standing waves. Okay, right, here we go. What makes such solutions interesting is that the Poynting vector is identically zero everywhere inside a finite-sized force-free field, and it cannot dissipate unless either its boundary is radiating or internal stresses make it break up. What makes such solutions interesting is that the Poynting vector is identically zero everywhere inside a finite size. So we have Schwerblis asked in 1988 for Nevesky to do a Maxwell equation treatment of what he saw as this bagel in this Moscow basement of formerly classified at that time Soviet energetics work. And Nevesky published in the journal Electricity in 1992-1993 that you would end up with a closed Poynting vector. This meant you can keep piling energy in and it would build and it would build and it would build, and that this would be the electromagnetic phantom. And that this could lead to, in the case of a Tor within a Tor within a Tor within a Tor, an electromagnetic phantom like that, an electromagnetic phantom like that, and that would lead to the ability to capture energy straight from vacuum fluctuations. That was in the Bagel paper from 1995 that I shared, and after translating it on remoteview.icu. I can show you that if you like. You can go and look for it. It's called the Bagel game. Then in 2009, there was this paper by Freiberger of Stanford Linear Accelerator, and he said, using a similar treatment, that you could end up with a diality angle passing a critical threshold that could cause the disruption and collapse of baryonic matter. That is effectively enabling the release of the energy in a proton or a neutron. So this would imply that this is a tool that can tear matter apart and also capture vacuum energy and trap it inside itself or use it for its own self-operation. This paper here from 1992 predates both the work of Nevesky, or it's around the same time as Nevesky in terms of published work, and it's predating the Schwerblis Bagel game and obviously predating the Freiberger analysis of what he called an explanation to ball lightning. The alleged simultaneous occurrence of the force-free time harmonic electromagnetic field and matching vortical fluid motion with a well-defined boundary will be called a plasmoid. Boom! They are saying that there is a vortical flow somewhere in this structure, and that allows for this effective non-radiating boundary, and the collection of those two things together is the plasmatoroid, is the plasmoid. Above the critical frequency, the physics becomes more interesting as the current is carried by the electrons and the plasma is at an energy minimum. The author believes that a number of observed phenomena, including ball lightning, fireballs, these are the things that we see in the Vega experiments, and charge clusters. Bearing in mind this was 1992, Ken had gone from electrum validium, strong electron, to charge clusters at this point. He hadn't moved on fully to exotic vacuum objects. So this was the name of Ken Shulder's work at that point. Charge clusters. When he was speaking to Feynman, he was referring to it as electrum validium. Then he realized it could have, for every 100,000 electrons, it could have one ion in play. And then he realized it was something much more interesting than just charge clusters and named it exotic vacuum objects. including ball lightning, fireballs, and charge clusters. We brought in together, just in the first few paragraphs of this, fusion, propulsion, plasmoids, ball lightning, fireballs, charge clusters at Edwards Air Force Base that occur in strong plasma discharges may be described in at least part by the plasmoids in this theory. Open questions of quantum and quantum electrodynamic effects and interactions with electromagnetic zero-point background remain to be investigated. It's suggesting here, as was suggested in the 1995 paper by Schwerblis, that the fractal toroidal electrodynamic structure could capture effectively zero-point energy. It is suggested here prior to that suggestion that this is a consideration that needs to be considered. Boom! Okay. Summary. Maxwell's equations allow time harmonic, that's resonant solutions, wherein the electric and magnetic fields are parallel to each other and both have the force-free form. Introduction. Bostic. We have Bostic mentioned here. Of course, he came up with the term plasmoids for short. Bostic described a plasmoid as a structure made of plasma, whose form is determined by the magnetic field it carries along with itself. So it's confined by its own magnetic field. Under different conditions, they may have names like anomalous discharges, charge clusters, and ball lightning. Here we've got another term, anomalous discharges, okay? And two other terms we've just seen above. A force-free time harmonic electromagnetic wave trapped in a stabilizing plasma vortical mode is chosen as a model. Using a standing wave model is not new. Kapitsa, as we talked through Kapitsa's 1950s paper, conjectured that ball lightning was explained by such a model. A model having a vortical field identical to a component of the electromagnetic field is not new either. So he's combining Kapitsa's theory with this vortical field. Wells explored such a model a number of years ago. What seems to be new is the combination of these ideas to explain some aspects of the plasmoid phenomena. I had no idea this paper existed. I'd read it a year or two, maybe 3 ago, but whatever. I only skim read it. But it's nice to come back to these things from where we are now. A vector field F will be called force-free if it obeys this equation. We won't go into all this, where alpha can be a complex valued function of the position. So they've got J current going through a wire and the magnetic component there. All the points lying on a given field line define a family whose locus on the surface is of a torus. A torus that approaches spherical overall shape, as in Fig 4. Where's Fig 4? This is Fig 4. No, that's Fig 2. And it's got various forms here, which I need to zoom out so you can see. Okay. So in this case, they give a bunch of equations where you can derive this. We won't go into it, but they're just saying by changing the R here to 4.49, the figure traced out by the lines is the topology of a torus. This is still a torus, but it's what's called a horn torus. Yeah, it has this thing going through the center. If the radius of the starting point was exactly at the first zero, the outer shape would exactly be spherical and the whole should have zero volume. So it's still a torus, it's still a horn torus, but there's zero volume in the central core. Okay. Depending on where you do your start on the radius, you end up with a fat torus or a thin torus. And I've shown you this in papers for fractal toroidal geometry as well. I think the first time I showed that was in the Ultra presentation in Azizi. Since the stresses in such a system would be minimized, it follows that the energy directly associated with the magnetic field must be at an extremum. The attempt is made to utilize this principle in the design of compact toroids and spheromax Now you can go and research Spheromax. This is the way they inject plasma into tokamaks, okay? And Spheromax have a similar kind of concept for how the toroid actually is holding the plasma together. In these devices, an effort is directed to produce force-free plasma regions that will have long lifetimes and thereby be hospitable for thermonuclear reactions. Right, so what they're saying is in these compact toroids and Spheromax, they're trying to do work to produce force-free plasmas to allow for thermonuclear reactions. They're already suggesting in here that fusion can occur. And what did I see in the presentation by Anatoly Klimov that I translated when he was talking in the presentation to Ed Lewis? There was a discussion that Kapitsa created ball lightning, just like Matsumoto did, but instead from high DIDT electrical discharges, he used standing waves in RF cavities using microwaves. And then there was a bit of discussion, and Ed Lewis said, but did he see any transmutation? And Anatoly Klimov replied, and I need to write to Anatoly and ask him to send me any papers or evidence of this. But he stated categorically that Kapitsa created ball lightning using resonant microwaves in a chamber and fused deuterons to helium. That is straight up fusion. Okay. Force-free fields were investigated in the 19th century by Beltrami, and everyone's should have known by now the Beltrami toroidal force-free structure. Both E and H can be expressed in terms of the vector potential A. So converting for the vector potential, you can have a look at these equations, enjoy that. If you perturb these particular parts of it in the J field, the current field in a force-free plasmoid above a critical frequency, a small perturbation of delta J of the current will add energy to the system. Right, so what it's suggesting here is if you've got a force-free system and you want to dump energy in there, and you'll see later that this system cannot expel the energy. So if you want to keep dumping it in there, you need to kind of like give it a little nudge, like spinning a spinning top. Keep giving it a little current nudge, a little disturbance, and then it'll capture that energy and it'll build and it'll build and it build. What I'm telling you here right now is how to build a reactor that will work. The condition for resonance is the vanishing of the total electric field and the normal component of the magnetic field at the cavity surface. This surface current produces no field outside the cavity. This is a non-radiating boundary, Only scalar and vector potentials exist outside of this. This paper is from 1991. Here's your spherical plasmoid and the cavity. They look pretty similar, don't they? A perfectly conducting cavity. I like the way they avoid using superconducting. But I would suggest that perfectly conducting it's the same thing as superconducting. Since the sign of the charge density must be negative, because the sign of the electromagnetic charge E is negative, it follows that electrons cannot carry the high frequency current in force-free plasmoids below the critical frequency. So you have to get it over a critical frequency in order for it to start the electrons carrying the current. There are several conclusions to be drawn from equation 38. Let's not go into the equation, but let's look at the conclusions. The first is that self-consistent force-free plasmoids cannot form below the critical frequency. When they can form, the free electron charge density must be uniform and increases quadratically with frequency. So, high frequency good, but you need to be past a certain frequency for it to work. A full analysis of stability will have to include the effects of the electromagnetic stresses internal to the plasmoid. It will be shown later that these stresses can, for the most part, be replaced by a pressure proportional to the square of the electric field, which can be cancelled by vortical motion. Really am trying to show you no equations. You don't need to. Well, as I say, all of the maths is done. Vortical plasma stabilization. Blah, blah, blah. As will be shown below, the pressure represented by the first term in this equation can be balanced by a vortical motion of the fluid in the plasmoid. In a perfectly non-viscous fluid, that's what we call a superfluid. I love the way they avoid saying superconductivity. Perfectly conducting, they call it. And they don't say superfluidity, they say a perfectly non-viscous fluid. It would also be possible to modify the velocities found in the outermost toroids of the vortical flow to compensate for the stresses surface currents would produce. Since the flows in separate toroids, now this is very interesting because it's the only place in the paper where they suggest there's more than one toroid in these structures, although we know for certain that in the first papers published by Winston Bostick and his team, and in the papers published by Bostick and Nardi, they were using at least 2 toroids to make any one of their plasmoids. Okay? So, in a perfectly non-viscous fluid, it would be possible to modify the velocities found in the outermost toroids of the vortical flow to compensate for the stresses surface currents would produce. Since the flows in separate toroids of the vortical motion, so they are suggesting here that this vortical motion is produced by separate toroids. And the rest of the plasmoid would be unaffected. The vortical motion is produced by separate toroids. This is why I think you need the wheel within a wheel within a wheel, minimally 2 at every single fractal level. Okay? But they don't spell it out. There's no diagrams showing you what to do, but we've done it. We've worked it out, in my view. The above analysis leading to the result that vortical motion can cancel the major portion of the electromagnetic forces on the electronic fluid. A fluid of electronic fluids? This sounds like Ken Shoulders speak. Fluidized electrons, electronic fluid, superconducting superfluid material. In small systems, there may be a component of pressure from a Casimir force. Casimir forces will arise in situations where, owing to the high conductivity of the plasma due to large numbers of free electrons, components of the electromagnetic zero-point background energy cannot penetrate uniformly into the plasma. This will result in a lower energy density within the plasmoid and an apparent pressure gradient due to the vacuum. It is beyond the scope of this note to investigate zero-point effects, but it's mentioning the zero-point effects. Okay, I like this bit here. Yeah, I like this bit a lot. There is a very special case that is worth mentioning, even though the possibility of its physical existence may be apocryphal. At the critical frequency, where omega equals C alpha, the current and charge densities become 0. It follows that a force-free electromagnetic excitation could exist in otherwise empty space. Boom! Electromagnetic phantom. There it is, a vacuum current described in this paper in 1991-1992. We have 3 people now. This group at Edwards Air Force Base, the Stanford Linear Accelerator group, and we have the Zverblis and Nevesky talking about a vacuum current / electromagnetic phantom. It follows that a force-free electromagnetic excitation could exist in otherwise empty, in inverted commas, space. The energy would be contained within a spherical region, terminated by a set of boundary currents. This is the non-radiating boundary, and could not radiate away. Classically, there is no limit to the energy density that might be confined in such an electromagnetic mode if the outside influences are large enough to contain the stresses on any surface currents that would be needed to match the boundary conditions. Let me say that again. There is no limit to the energy density. This is exactly what I've been saying for years. You can build at that phase singularity over and over and over and over again until you reach the energy density that would be the Schwinger limit, and you basically have the core of a black hole at that magnetic core. And then not even light can accept. It can go in, but it can't come out. It just becomes part of the Borg. If such an object could exist, the limit on the field strength would be near the point where the vacuum polarization, boom, due to virtual electron and positron pair production was affected. It would polarize the vacuum. Classically, and I like this term they've used here, such a vactoid, vactoid, this is a vacuum plasmoid. Okay, write that one down, vactoid. It sounds like something they're going to put in your arm. Run away. Would be almost undetectable, assuming the correct terminating currents. The electromagnetic fields immediately outside its boundary are nil. So you could have something that has a black hole in the center, essentially, that kind of intensity. It's got the Schwinger limit going on. But on the boundary, you don't see any electromagnetic fields. And no charges inside it are present to radiate. A more modern view says that the trapped energy represents E equals mc squared mass and would have a gravitational field. It has a gravitational field. Also, scattering from virtual electron-positron pairs might eventually lead to the decay. Unless there was a direct contact with ionizable or charged particles, the presence of an individual vactoid would go unnoticed. Lack of surface currents leads to the apparently illogical consequence of a standing wave having no sources. This is very, very important. What are we talking about here? This is about how to make them in the first place. Lack of surface currents leads to the apparently illogical consequence of standing wave having no sources. How could you make a standing wave with no source? Well, here it goes. In the literature, such waves have been called diffractionless, phase conjugated waves, comma, electromagnetic missiles, and Bessel beams. There's something for you guys to go and look up now. Bessel beams, etc. So, phase conjugated waves are the means by which you can trigger the production of these structures and energize them. A force-free plasmoid, unterminated by surface boundary currents, may fall into this category. The magnetic current M can be only approximated by normally charged particles, since magnetic charges evidently do not exist. I like the sarcastic kind of tone there. Evidently do not exist. The purpose for this discussion is that if a real steady-state force-free plasmoid were to exist, with non-zero fields inside and free fields outside, some mechanism would have to be provided to sustain multiple layers of sheet currents on the surface of the plasmoid if there are discontinuities in the fields. No such mechanism immediately comes to mind. But it's definitely not anything to do with a magnetic charge. Can't be to do with that, but we don't have a mechanism. Can't be to do with magnetic charge at all. No, can't be that. But we don't have any mechanism. Are we getting there? The general questions of terminating the surface of a plasmoid probably cannot be answered easily without more work. Anecdotal evidence seems to indicate that the autonomous plasmoids responsible for ball lightning do not have external supportive fields that need to match stringent boundary conditions. On the other hand, workers in Japan have produced plasmoids with exceptionally long lifetimes in cavities, sustained by microwave generators. Apart from surface boundary considerations, a picture emerges concerning the description of a spherical plasmoid with a trapped electromagnetic field inside it. A trapped electromagnetic field inside it. High field strengths might be required to initiate small energetic plasmoids. This is exactly what Ken Shoulders does. This is exactly what is done by S.V. Adamenko. You name it, high field strengths might be required to initiate small energetic plasmoids. Alternatively, the plasmoid could be thought of as a lossless dielectric material. From equations 12 and 14, this material would have effective permittivity. Okay, so we're having a change of permittivity here going on in the plasmoid. This is going to be interesting. Note that it is possible that the effective permittivity, this is the permittivity effective, is less than the permittivity of the vacuum, epsilon 0, implying a superluminal phase velocity within the plasmoid. Boom! There it is. We have vacuum permittivity changing, the dielectric constant, the physical vacuum, okay? And that within the plasmoid, it changes. Now, this is before, as far as I can recall, Ken Shoulders writing his paper, Permittivity Transitions. Okay? And they are suggesting that this is the way that it is, and that within there you have superluminal speed, because you are changing the physical vacuum within it. The plasmoid region will have internal vortical motion that will cancel the tendency to expand due to electromagnetic pressure. A remarkable accident, in inverted commas, may therefore exist in nature, wherein a non-propagating electromagnetic field and a special vortical fluid field with the same functional form, neither of which could exist separately, can combine to produce a long-lived high-energy density plasmoid. The outer supportive field, since it cannot exist in a vacuum, would have no need for vortical material motion for stability. These are self-structured things that do not have a problem with being in a real vacuum. You can imagine that if you are drastically changing the speed of light within these structures, that will affect all nuclear reactions going on inside. To produce the plasmoids described in this note, the following steps must be included. Closed spherical vortices must be produced. Not a closed vortex, but closed spherical vortices must be produced. You need to make a lot of these things. Desired levels of ionization must be maintained. Let's have some charged particles in there. Electromagnetic energy at frequency omega must be produced within the plasmoid. So have some scalar waves, some phase conjugated waves, some microwaves with, 180 degrees out of phase, standing waves, okay? If, however, the plasmoid region was traversed by a column of current whose axis was parallel to the axis of the plasmoid, the field of the plasmoid can be pumped. That's tickling your little thing once you got it made. Ken Shoulders made these and then he grew them and he grew them and he grew them. From what has been derived in this note, a possible scenario can be envisaged for the creation of a spherical plasmoid. A very strong discharge occurs in an ionizable gas. Well, isn't that exactly the process by which Tesla was doing his demonstrations? He was using a disruptive discharge in air. The ionizable gas is oxygen and nitrogen. the disruptive discharge is producing the very strong discharge. And these do produce monopoles. The monopoles then go into metals which are collecting, which are themselves static electricity. The monopoles build and they get energized by scalar waves, that is, phase conjugated electromagnetic microwaves. You can see some frequencies a little bit later on, and this would lead to, boom, the Hutchison effect. The pinch effect a very strong discharge occurs in an ionizable gas in the presence of high-frequency electromagnetic field. The pinch effect due to the discharge initiates a compression, which turns into a swirling vortex. At the right level of ionization, now, we know that the swirling vortex produces, if it's correctly configured, it will have a magnetic vector going through the center, and if they then link up with their magnetic vectors into a toroid of torides, then it will produce a toroidal moment, and then it can then self-organize through the toroidal moment. At the right level of ionization, the external time harmonic field is expelled from the vortical region, and radiation from the column of the discharge inside the vortex at the same frequency as the external fields cannot escape. At the end of the discharge, a highly energetic plasmoid emerges that has nearly as much kinetic energy as internal electromagnetic energy. Created in a quiescent ambient gas with a low kinematic viscosity, the plasmoid will slowly come up to a speed that is comparable with its tangential gas velocity. That sounds like propulsion to me. At early times, the plasmoid could appear to move very slowly and may respond to ambient gas flows. Catastrophic demise can occur if the radiation does not leak away at the same rate the fluid motion dissipates heat via viscous forces. The fluid and electromagnetic forces will not balance and the plasmoid may come apart. On the other hand, variations in the external fields could cause boundary mismatches that might also lead to catastrophic decay. And this is what I'm saying. If you attack these with external fields, you might be able to cause them to fall apart. That's how you break them. For lifetimes, but some reasonable values for the parameters might be. So this is actually talking about a practical thing that would be a bit like ball lightning. If I go up here, I think this part of the title, it talks about how to make something. Anyway, we'll come back down. And it talks about a practical implementation here. Right. Some reasonable values for parameters might be the radius is 10 centimeters. So we're going for a ball lightning of 10 centimeters. Lambda equals 1 millimeter. And zeta equals 0.01. Under these conditions, a 10 centimeter radius spherical excitation may have a total energy density of the order of 10 to the 8 joules per meter cubed. This value is larger than the average reported energies of ball lightning. And these excitations may represent electromagnetically excited fluid state that could serve as a model for ball lightning-like phenomena. What am I saying here? Okay. If the radius were shrunk to 1 millimeter, the total energy content would be about 15,000 joules. The wavelength of the harmonic wave would be 10 micrometers, and the energy equivalent to a 50-watt light bulb burning for 5 minutes. So one 10 micrometer structure would be able to light a 50-watt light bulb for 5 minutes. Now, in the sadly departed work of Neil Crichton Gold, the Lion reactors, in the first reactor, he turned off the power supply, and to the electrically isolated bolt that was attached to the copper wire, he put a 20-watt light bulb, halogen light bulb, and it lit for 30 minutes. This is a 50-watt light bulb for 5 minutes. So if it was, it'd be 2.5 times that, it would be 15 minutes. It's almost comparable. So I would suggest that one 10 micrometer or a number of 10 micrometer which is compatible with the kind of things that we see in the crust of the Lion reactor, they were breaking up and releasing their electrons, and the electrons were going through the light bulb to what Neil Crichton Gold described as a drain. Now, sadly, he wanted to reserve that for the Cavendish lab at Cambridge. And he never told me what that is, and we haven't found a record in his library, his archive that we have. That being said, I always suspected, because John Hutchison said these things, they can infect metals and they like to go from one metal and distribute themselves, I suspected it was a large lump of metal that he was using. And when we went to clear his effects out, we found very large copper and aluminium grounding rods. They were, I don't know, at least 1.5 meters long. And I suspect those were the drains that he was referring to. And I think what was happening is you've got a lot of charge clusters over here, and they're breaking up and they're migrating through the light bulb and into the drain. I think this is totally consistent. So I think in Neil Crichton Gold's reactor, and at the same time, the reactor was freezing. So it was cooling at about 1,000 degrees per second, and it was crackling, and it sounded air was being sucked in. And this is all consistent with the thermal losses that would have been the radiation as the matter was condensing, and as these electrons were coming out of the coherent state in this new phase of matter and becoming normal electrons again. They needed to regain their kinetic energy, so they sucked thermal energy out of the environment, phonons in the IR frequency range. And that would account for the sucking, it would account for the massive temperature shifts observed on a K-type thermocouple in the data, and also in the fact that the copper oxides looked like they'd been splat cooled, which is over 1,000 degrees a second. That matched the data on the data card. And this was the exotic vacuum objects coming out and becoming ordinary electrons again and sucking the thermal heat to get them to be at the temperature of the surrounding material. Okay, so I think Neil Crichton Gold had achieved something very similar to this with his reactor. Numerical. So here's a numerical example. On the basis of anecdotal evidence, very energetic plasmoids known as ball lightning may have total energy content. So here's the thing. When anyone accuses you of mixing up terms, ball lightning and plasmoids and charge clusters and EVOs, just don't worry about it, because you're in good company. Because Edwards Air Force Base and the top scientists funded at the top institutions in the US, that's what they think they are too. So can we just get over this thing that ball lightning isn't the same thing? Very energetic plasmoids known as ball lightning may have total energy contents of 1 megajoule with a radius of 10 centimeters. With no further justification, it will be instructive to calculate a set of parameters that could produce such a force-free plasmoid in the Earth's atmosphere at sea level and at 0 degrees centigrade. So for a sphere with a radius of 10 centimeters, from the equation above, assuming that L equals 1, the plasmoid with a radius of the first set of blah, blah, blah. So this is our alpha, so this is basically a sphere. Assuming K will be large enough to ignore blah, 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 blah. That's the volts per meter. And here is the thing you really want to know, 126 gigahertz. Okay, 126 gigahertz, which is equivalent to a 128 gigahertz field. There we go. Non-radiating harmonic fields that can confine plasma currents and charges. So this guy is Jack Nechamkin, who did a lot of this work at Edwards Air Force Base for the Phillips laboratory, this propulsion laboratory. Any references to a non-radiating mode in this note will always imply reference to a force-free non-radiating mode. Some of the results of the simple theory may explain experiments performed by Bostic and his associates, that would be Nardi as well as results reported by Puthoff, boom, and Shoulders, bada boom. Okay, so here we go. We have Bostic, Puthoff, and Shoulders. These people at Edwards Air Force Base, where I had been told there had been this over-unity energy production, a direct electrical production device based off Shoulders' work was done. They are clearly seriously investigating Ken Shoulders' work and the work of Hal Puthoff. The idea of applying the force-free mode to confining plasma is not new. Techniques employ names such as spheromac and compact toroid, which nominally depend on force-free plasma motion, have been implemented with varying degrees of success. In these schemes, the object is to induce the gross fluid velocity of the plasma to conform to a Beltrami vortical mode. This lowers the magnetic interaction energy and presumably raises confinement times. Blah 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 blah. Okay, just have a look at some of these references here. Oh, number 2 reference is Bostic, Winston, and it's the second international conference on energy storage compression. Energy storage compression. Well, isn't that interesting? Listen to what I just said about what was observed by Neil Crichton Gold that matches what is claimed in this paper. His observation was predicted. Now, did they observe it in their work? They didn't say they did. They just said it should be possible. I didn't know about this work, and I don't think Neil Crichton Gold knew about this work, but he observed what they said should be possible. And here you have Bostic working with, oh my God, look at the end here, Harold Puthoff. This is a personal communication between Bostic and Harold Puthoff in 1990 when they're all working together at the Conference on Energy Storage Compression. Oh dear. Who else we got here? Oh, there's Puthoff here. Condensed charge technology and its potential impact on the electronics industry. Well, isn't this a list of usual suspects? God bless them. And what have we got down here? Nardi, personal communication. So there we got Nardi, Bostic, Shoulders, Puthoff, Kapitsa. We've got all the usual suspects. All right, well, who we got down here? Anyone interesting? Don't know. Oh, there we go. We've got Kapitsa here. We got Bostic, Bostic, Bostic. Oh, here we go. This is the same one. It's the same reference here. Oh, no, it's a different place. Venice, Italy. So, yeah, Bostic with Puthoff condensed charge technology. Very, very interesting. Very, very interesting. Probably all these papers are very interesting. Look at that. Right, so that was... let's go back to the beginning with our pointing vector. So we have effectively a closed pointing vector. We have our 0 point here. We have our ball lightning mentioned, a standing vortical wave. We have our spherical torus here, thermonuclear reactions going on in there. We have a non-radiating boundary. We have blah, blah, blah. Separate toroids mentioned here, somewhere here. The fact that there are separate toroids going on. Casimir and the 0 point. Vacuum currents. Third paper discussing this. Self-sustaining ball lightning. How to pump the plasmoid. How to make the plasmoid. Using it for energy storage. What the energy would be in a 10 centimeter ball lightning and how to create it in theory. And so on. Okay. And then Harold Puthoff and Bostic as a personal letter between the two, if you had any doubt. Right. So, this point, I'm going to give you a different thing. I'm going to show you a practical demonstration. So, if you bear with me. Here we go. Look what I have over here. Hello, hello. Somewhere here. There we go. Over here. Oh. There we go. Right, ready? Isn't it pretty? Isn't that pretty? What is it? It's a plasma toroid. And the interesting thing, it sticks in position here. If I can rotate it round, I can rotate the toroid. It likes to keep its position. Very pretty. You can get it to separate into substructures as well. There you go. You saw it just. It's funny. If I add a bit of shear, it goes into a smaller torus. So, it's a pretty simple circuit. It mostly is a fan down here. That's mostly a fan and a heatsink. That's almost all of what it is. And then a pretty simple circuit here. Producing some pulses at a variable frequency and a low pressure filled bulb here. So this one was actually given to me by Paul in Canada. He had it here as part of our energy conference. And I'm going to talk about how I would consider modifying this such that we can achieve what we want to achieve, possibly in terms of propulsion and in terms of energy production. I can go and grab a magnet if people want me to do that. Let's go and grab a magnet somewhere. I've got a magnet somewhere. Let's have a look up here. One pretty darn strong N52 magnet. It isn't above 60 degrees, so it should be okay. Let's see what happens here. That's not seeing a lot there. Well, that's interesting. Magnetic field's not having a lot. Just to show you, this is a very strong magnet. I don't know, what can I do? Get a large piece of metal, show you it, grab it. I don't know what. Try not to have too much metal around. Let me get some metal. Okay. Yes. So ND52 magnet. It's pretty darn strong there. Okay. So we'll try and see what we can do with this. All right. I've got the magnet on the end here. Let's see what happens when I go in there. Barely making a difference. I can move it around. A little bit of bending going on there. Not a lot. Oh, kick it out of position. See if it likes the other pole. A little bit of kinkage there. Right, okay. I'm going to play with the frequency with the magnet in play. Oh, so we've got a little trail coming off at one point with substructures in it. Oh, look at that. That's quite fun. Oh. Well, there's a standing wave there forming of its own accord. Oh, nice separation there just a second ago. Oh, look at that. Lovely. Yeah, the toroid splits up. Okay. That's that. that was your interlude. Okay, so I have referred to this paper in the past, which is from the group at Aalto University, and I have shown that the model that I have for the monopole is, in my view, more accurate than their whatever mathematical model they're using to produce these. So this is the Ukonopsara. This is the spin flip that occurs. So this is spin one way, this is spin 0, and this is spin the other way as you go through. And when you overlay this, as I did in O'Day Another Dimension, you can go and look at that. When you overlay it on here, exactly and precisely matches every single feature that they have here. And this is from a Bose-Einstein condensate, and they're looking at it through the side plane somehow. And you can go and see the videos of that here. And this is through the top plane. This is the synthetic view. And the wheel structure that I have predicts better what you see in the actual experiment, because there is this S here. There's this S. And when you overlay the geometry that I have here on here, at the same scale as the geometry as here, but viewed through the top, you actually end up with the S that's in there that produces the vortex. Okay? So I've given this paper link in the past. I will do it again in the notes for this show. Now, there is a separate paper which I looked at, and it's this one. And we'll actually look at this paper in a second. But the key point here is that this is a ball lightning. So this is a synthetic monopole. And like they were saying in that paper, they were basically suggesting that you needed a monopole to be able to do this, but since they don't exist, we don't have any idea what else could cause it. Well, this is a topological monopole. This is, in my view, the structure of ball lightning, or one form of them. And here, when you look at the top here and you overlay this on here, this is a microwave ball lightning paper. And when you overlay this structure on here, their non-radiating boundary, this dark area that they have here, exactly and precisely marries up to the non-radiating boundary here. Theirs is a 4-Tor structure, so I've got a 4-Tor structure here. So you end up with the 4-sided structure as I was showing you on the impact marks. Now, the interesting thing is, in this chart down here on the bottom left, you have a high electron density going around the torus. Okay, as we're discussing in the other paper, that would be the vortical flow, the Tor in there that's actually enabling this non-radiating boundary. But this part here, this red line here, is 0 field. So at this point here, there is zero field intensity, absolutely nothing. Okay. However, in the center, you have the highest intensity of field. Okay? So the electrons are spinning around like this, or rather the magnetic field is going around like that. So it says down here B, field energy density and plasma density NS versus a Y across the bubble center. Is that B? No. Oh, sorry. Magnetic field B. Okay? And this is the direction of the magnetic field. So if you have a spinning magnetic field in there, you will have a toroidal moment coming through the center. And the toroidal moment has the Aharonov-Bohm effect, and that produces, with the electrons going around, this intense field in the center. Interestingly, when you've got this NE here, that is any, sorry, this one here rather, Ni, is the ion density. Okay, so is that implying the ions are more dense in the middle? Maybe. Okay, So when we're looking at a 4-order structure, here's 2 examples. This is a 4-order structure in the outside of the 15 millimeter cut copper section from Henk-Uren. And so you can see it really is a square, just like they had here in this simulation of a microwave-produced ball lightning. You have this square here, squarish hole in the middle, squarish hole in the middle. In this swastik, in the copper of the tube that actually lit that 20-watt bulb for 30 minutes, we have the remains of what I would say, or the shadow of what I would say is an exotic vacuum object trapped in the copper. And this is the form that would have been caused by. So this is actually rotating around this way, the magnetic current. This is rotating around this way, and this is rotating. These are all rotating around the same way. In this image, it's rotating around the other way. It's rotating. The magnetic current is rotating around the other way. Okay. So I'm going to go and show you this paper next. So let me just get that up. And it's in Nature Scientific Reports, and it's relativistic microwave theory of ball lightning. And so they're talking about electric field and blah, blah, blah. This is it's kind of a bit like Kapitza going on. You end up building in this sort of way. You end up with your birdie type shape going on. But here is the diagram that I have been referring to here. So it's a microwave self-trapping bubble formation. And there we go. So who would have thought that my simple model here would be able to accurately depict both a microwave-based ball lightning structure and a Bose-Einstein condensate sort of structure as well here. Okay. Right, now we have Roth here from 1994, talking about how ball lightning could let us understand how we could produce fusion. Well, we know that. And here in this paper, there's a very interesting, some details here on the ring vortex solitons in non-local, non-linear media. And it's saying here, we study, and I'm not showing you, so I'm going to show you here. Sorry, that was the Roth paper here from Fusion Technology, submitted December the 20th, 1993, talking about ball lightning being important in there. Right, so in this is ring vortex solitons in non-local, non-linear media. And the reason I'm showing you this is because of its relevance to the phase singularity and its relevance to breaking up and disruption of what you should observe when a coherent matter falls apart that is born out of a phase singularity. And I think this is basically going to wrap up any person that thinks that this isn't how it occurs. Probably, hopefully. So this is from 2005, Optical Society of America. We study the formation and propagation of two-dimensional vortex solitons, i.e. solitons with a phase singularity. Our results pave the way for experimental observations of stable vortex rings in other non-local, non-linear systems, including Bose-Einstein condensates. So I was showing here stable ring in a Bose-Einstein condensate, or stable structure. This is a stable kind of structure, but in what I would argue is a condensate of electrons. And they are looking for, this is a photonic base, but they say that this should probably work in other systems like Bose-Einstein condensates. A soliton is a localized wave that propagates without change through a non-linear medium, such as localized waveforms when the dispersion or diffraction associated with the finite size of the wave is balanced by the non-linear change of the properties of the medium induced by the wave itself. Solitons, a topic of great interest in recent years, are universal in nature, having been identified in such diverse physical systems as fluids, plasmas, solids, matter waves, and classical field theory. In the field of optics, solitons hold ongoing promise for their potential application in telecommunications and all optical switching. The soliton concept is also important in the context of Bose-Einstein condensates, where it represents a stable, localized, coherent excitation of the condensate. Depending on whether the bosonic interaction is attractive or repulsive, bright or dark, Bose-Einstein condensate solitons can be observed. In recent years, so-called bright vortex or spinning solitons have also attracted a great deal of attention. These are finite-sized beams characterized by a phase singularity at the center. The phase of such beam rotates around the singularity, the number of rotations defining the topological charge of the vortex. Extensive numerical and theoretical investigations showed that the vortex rings decompose during propagation into a number of filaments that travel off tangentially to conserve the total angular momentum. And I can basically show you the diagram. Here we go. You ready? You ready? You ready? There we go. Here's our soliton. It's traveling. It becomes unstable, and it goes one vortical beam and another vortical beam. Where, oh, where have we seen that? Where, oh, where have we seen that? Could it be that we saw such a thing in the Henke and Vega experiments? Could we have seen that? What am I going to call it? You can go to this one, which is Vega Even More Extraordinary Traces. Okay, and you can see here there's a video and I talk about it, but you see this thing explode and this comes out here. What you're seeing, each one of those is 1/60th of a second. This is on Ken Shoulder's exotic vacuum object impact marks, and you see an exotic vacuum object that's come through here and here, but also he has this trace here, which has gone sideways through the structure, and I believe that's a small exotic vacuum object, which is a substructure of that thing. The soliton's breaking up into substructures, and it's going through with this helical type pattern. Here is another one. This blew up and at least one came out here, and you can see here the 1/60th of a second frame. So you can see this is a fireball, and so from the paper from 1991-92, we have seen that fireballs are considered the same kind of force-free toroidal plasmoid structures. And here we are, we have our fireball. This is the traditional name for a tuft, as the Sapphire Project called it, in our reactor. And when that disrupts, it sends out a vortical beam. And then when I attach the beam together, it looks like this. And this is equivalent to that released in the work of Dmitry Baranov and captured and actually manipulating the material. Here is two beams coming out, just like you saw in the paper. And we have the two beams coming out from two camera angles. Two beams from two camera angles. So yes, that's what it does. And there's actually a video of that somewhere. We've got the video of that. Okay, so that's 1A from two different angles. Okay, So this is the same sort of thing as you see here. The coherent matter blows up and it sends out these vortical beams. And in this case, we caught both of them, just as is shown in that paper. Where is it? Not there. It's, where is it? Oh, it's here. There we go. So our soliton is here and it breaks up and it fires out two beams. This is the prediction. And I believe this is the actual reality from a Bose-Einstein condensate formed by fluidized electrons. And this is equivalent to that shared by the former head of technology, Jean-Francois Genest, in 2015, and he called it strange radiation. And it was presented to the European Agency of Defense, Air Defense, by Claude Devial in 2010. So that is the mark on some material when they were replicating the exploded titanium approach of Leonid Rizkiev, which we know produces monopole charges, ball lightning that breaks up into microball lightning, transmutation, all of the things that you would want, and plasmoid marks. Okay, so here's a whole bunch of them. And that is it. So I think with this particular paper now, and I thank Tiziano, I think the Italian guy, thank you very much for sharing this paper with me. And it says, in the weakly and moderately non-local regime, all vortex ring solitons experience azimuthal instability and break into filaments after certain propagation distance, as seen in figure 2a. That is about that. Okay. Right. So where am I taking you with this? I'm taking you to here. This is our torus. What I've done is I put it in the middle of the Tesla Wardenclyffe Tower. And I believe that the fields here produced by these capacitive arrays here down the bottom here, as far as I know, I think there's 8. There's like 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there's 7 capacitive plates here. And there's 48 divisions around. And what I believe you need to do is indicated by what we learnt from the beginning. From how we derived the fractal toroidal geometry structure. And that is from John Hutchison's sample here. Not that one. We'll come on to that one. Let me do this in a different way. Okay. What's it doing? Hey? It's choosing what it wants to do. Here we go. Sorry, I'm not asking you to go ahead. Okay, I think it's settled. Yeah, so as we learned from this, it's sweeping the material around it. It is not moving, but it is one of these plasmoid structures. And so that leads me to believe that these things are their current loops, they're vacuum currents, but they affect spin and other material around them, but they're not actually, this isn't rotating around here. So, whereas on this device over here, this one here, we are basically creating just a torus around the outside, okay? I think we need to have phasing up in regular arrays, and I think just like the proposal for intergalactic drive, all we need is 6 would be good enough. I think because we know that 6 allows for the flower of life, doesn't it? We know that 6 allows for the flower of life. Here. Not that particular one. We'll do a different one. Okay, tools. Okay. 6. We'll get to 6. 6. This one. 6. That one. 6. I think that will allow us to do what we need to do, because it's nicely represented here in the Schwerblis paper, and it's represented here in the 1979 paper. And where am I drawing my inspiration from? Well, I'm saying that when you have the ARV, it has 48 of these around here. That's the maximum. Now, I believe that it's phasing in this direction. As far as I understand, this is a special type of quartz. The quartz, with the thickness of this, it's able to support 1.2 million volts. And that's over 1.022 million volts necessary for vacuum interaction, polarization. And so by phasing the capacitor arrays up here, you can then start to cause vortices. Yeah. So if you've got your plates like that, it doesn't matter that you've got wood and then lead paint on the outside. The capacitance will go through that, and it'll start doing this vortex and producing what's necessary here on these edges. And where the notch is in the Ukon Vasara, 1600-year-old Ukon Vasara from Finland, in the Thor's hammer, which was completely ripped off by the Tesla logo, that is probably where you'd want your people, and indeed that is where the people are here. And so essentially what you're doing is you're getting a gravitational azimuth that goes through the center. Okay. And in the central column, there will be energy produced. I will talk about in a separate video, I will talk about the importance of the aluminium homopolar generator here. There's some very, very interesting thing that occurs with that. So that'll be a more dedicated video for this. But essentially the same kind of thing is occurring in this one, where it creates ions from this corona ring, and then it has phasing on these rings. And whilst it looks like it's a ring going all the way round, I imagine it's split up into sections, allowing the vectoring to occur based on various parts of the device. And in this one, by the British Railways Board, they have a nuclear reactor producing particles. And again, you've got phasing here. They've got 1, 2, 3, 4, 5, 6, 7 plates. And it might be that these are the conductors here. It's actually got 1, 2, 3, 4, 5, 6. It might be that this is 6 conductors, or that these are the conductive plates. One or the other. This might be the insulation. I could read it. Either 17 is the dielectric, or 16 is the dielectric. Probably, I don't know. It doesn't really matter. One or the other. And you can phase here, but the other thing is you can also phase round this way. Okay, and that's true of the ARV. You can phase around this way, but I think because these are closely linked together, I think the main part is to get this part of the vortex going, okay, which is where the action really occurs, okay. And how I would do it on this little puppy here is, rather than having that ring just making the torus, you want to be able to create six capacitive phased arrays on there. You still probably need the kick and the ionization in there to get it going. But the reason you want these 6 zones around the outside is to allow for the magnetic loops in the plasma. So, sorry, the current loops to go like that. And then that will produce the magnetic ring. And it's the magnetic ring that will then produce the toroidal moment. If anyone does this, can I just ask people to make sure they play really, really safely? Because if they spin this up, it might disappear very, very, very quickly. Okay? Or it might blow up. In theory, from what we've been reading and what we understand and what we've seen in experiments and what John Hutchison has seen and so forth, this kind of concept should be able to capture energy from the physical vacuum. And if you're looking at this, right, with the Mark Candlish, this produces the torus on the outside. I'm suggesting that we produce the torus on the inside. And so rather than having to have a particular gas on the outside, we've already got our gas on the inside here. And by creating the thing in there, we might be able to create the gravitational azimuth. And by phasing these 6 locations, just like on the McCandlish one, they have this little handheld control. You can see in the seat here. And you move that, it's just like a ball on a cup, and like you move your hand like that, and that just changes the angle. And all that's doing is changing the phasing on these to change this one torus on one side so that the net gravitational vector points in a particular direction. So that allows you to move left and kind of right and pitch and yaw in this case. The same would be true of a device where you're creating the torus on the inside. And if you work this well enough and you've got the gravitational azimuth going through the center, then you could actually either pitch these so that the gravitational beam would go out at different angles, or you could even rotate the entire structure. And this would be the kind of propulsion that I would imagine would be on something like the TR3B, where you would have 3 spherical zones. That the plasma you need is already in there, so it'll work everywhere. And you either phase the array that you have around it to point the vector, the gravitational vector, in a particular place, or you rotate the actual structure with the electrodes attached to it, and that's it, basically. So, Gordon, we nearly finished, so you can go to bed. Yeah, well, this is what I'm saying. So Alex Lesman said you can't rotate the plasmoid by rotating its container. I'm not rotating its container, okay? What I'm saying is you either you phase faster or slower on each of the 6 capacitive arrays you have on the outside. You change the speed at which you're phasing those, just like I'm saying the ARV works and the British Railways Board device works. Or you rotate the whole thing that has the electrodes attached on it, and you're just pointing the gravitational vector in a different direction. Yeah? Does that make sense? Okay, so we'll just put this back on the stand, and we'll switch back to have a look at it. It's rather nice. So I think if I get this in maybe a stable position, can get it to go stable. Come on, be stable. Right, okay, it's not being stable, is it? Okay, got it somewhere stable like that. And what I'm saying is, rather than having just the one ring like this, you actually got 6 rings, and the rings will then make a proper wheel within a wheel structure, which will have a toroidal moment, okay? And in theory, if I pick this up, I should be able to move this, and it's actually taking a gravitational azimuth, which is interesting. So forget what I said. Actually, you need to phase it. It seems to like to want to point to the gravity. So that's interesting in itself. Well, let's get it stable again. Let's see if that does what I think it just did. Right, so we got it stable there. I'm trying to hold this in position. Am I varying it? No, I'm not varying it, right? Yeah, it's moving. That's interesting. I don't know whether I found something there or that's just an artifact. Let's see. In that case, it's not moving because it's not stable. It's interesting. It doesn't make any noise when it's using less power, and you know it's using less power because the fan turns off or turns down. Right. So when it's nice and stable, it's using a lot less power, it would appear. And if I pick this up, oh, I lost it. If I go like that, is it going to do it better like that? Okay. It's not very scientific, this, but anyway. Oh, there we go. Yeah. Okay, so that's interesting. It seems to want to orient itself with gravity, which in itself is very, very interesting. Yeah, my own magnetic field is affecting it, but not so much, you know, a little bit. But anyway, I believe that you need to have these phasing arrays on the outside, and by phasing them, it'll completely change the vector of the gravitational azimuth. Yeah, it might be the relic neutrino flux. We don't know. I'm a little scared with this thing because my understanding of how these things work. I'm less scared of this because it is just the one loop. But if it was a loop of loops, I'd start to get a bit scared of it because it might do some very unpredicted things. In theory, if this was not just one loop, but it was a loop of loops, in the center, I would expect it to start cohering vacuum energy, because you might end up with a scenario which it's describing in that paper, that you get energy going in and in and in and in and in. And in fact, I would want to be very far away from it. Very far away from it. Because that would be quite tedious. Because it could explode. Or it might produce a lot of heat, it might produce a lot of light, and I wouldn't want to be near it. But, yeah, go darken into your body. So, I think by doing what I'm suggesting here, we will end up by having unlimited energy production, and we will have propulsion. And on that note, I want to now talk about what has been revealed today with regard to the testing party of Andrea Rossi. So I have to thank Mako Marzocchi, and he did a whole bunch of additional tests which were not revealed before, but he revealed them today, and these are the tests. He had prepared a heating resistor system with running water cooling to verify that the ECAT could be used as a heating source. In my box, there is a sink with a water tap and a drain for draining water on the floor. He then did a trolley, a transportable trolley called an ECAT wall box, completely made by him and completely controllable wireless in power, that took the DC input from the ECAT, and it could recharge the box without any problem. then a full electric car according to the T2 standard, and at the same time was able to provide this power, electrical power, without any problem to various types of load, resistive, inductive, etc. He then rented a BEV electric car and specifically a Volkswagen E-Up, and he used that as a load for the ECAT wall box. He then did a test with a 500 watt power drill and a 2 kilowatt fan heater to verify that the ECAT wall box interconnected to the ECAT with an additional AC output was able to drive it without any problems, total power of that type, and it's resistive and inductive loads. Okay, so essentially what happened, this guy Mako Marzocchi, or Marzocchi, I'm sorry if I get your name wrong, Mako. He had prepared a load of tests, and Rossi didn't know he had prepared these tests, but when Rossi turned up, he said, look, I've done these extra tests, can I do them? And he said yes, and that's pretty impressive in my book. Through my electronics, I remember that by pressing the button on the side of the box, you can exclude all the specificities and behaviors necessary for management and integrating blah, 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 which gave me blah, 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 blah. Okay, so he shows the stuff he's got here for the heater. So this looks like a reasonable heater setup. It's got a load of immersion heaters here, and looks like a pressure cooker pan here that he used. Here's the wiring on the back, and he's got these cooling pipes. And so it was set up like that. This presumably is the ECAT. Not entirely sure, but something like that. And there's the setup, and this is his water supply, I guess. So he did a thermal heating test with it. He then did once that test was completed, they connected this thing to a wall box and recharged up a Volkswagen E-Up for 1 hour, introducing about 2.7 kilowatts. The ECAT produced more, but in this case, the conversion losses of the car's onboard charger also intervened but there was no problem. Okay, so let's see what we're looking at here. For me, okay, so this is his device, which he used, trolley thing to allow charging. This is his wall box converter, I guess. And then they charged this car, it would appear. That's the claim. And then what they did was they used that same device that had been charged by the ECAT with 1.2 kilowatts without any problem. And apparently they then drove or ran again, it's the E-box here. And then they drove a power drill and a heater, fan heater, 2 kilowatt fan heater. And apparently those devices worked as well. So resistive and inductive loads and DC charging, I guess. And so I encourage you to go and look at this article on ECAT World. And the other article I would get you to look at is, I actually bothered to read for the first time properly, Andrea Rossi's paper, which looks like, by reading it, it's been following a lot of the work that I've been doing over the last several years. And I think it's probably been written by Giorgio Vassallo. But anyway, that may be or may not be. If it isn't Giorgio Vassallo, then credit to the person that did write it. If it is Rossi, then that's interesting too. But if you look at this paper here, in theory we'll get it here. Okay, so he talks about charge clusters, he talks about Aharonov bomb effect, and he talks about the Aharonov bomb effect after I released the paper or the patent from Lockheed Martin. He talks about shoulders and charge clusters and so on after I made those things available. But whatever, it's about synthesis, isn't it? So we've got Aaronhoff on Bomb here. We've got Di Tommaso. I think these guys are involved. I think Tommaso and Vassallo. And this is about their model of the electron here. We've got Harold Puthoff mentioned here. We've got the Carrere brothers, and this is talking about discharge type systems. Again, we've got Tommaso and Vassallo here. Dirac's monopole theory here. No, this is the theory of electrons and positrons. So this is about vacuum polarization. Okay. Dark matter we've got mentioned here. Bernie Heisch used to work with Hal Puthoff in the modal quantum vacuum energy extraction. Andras Kovacs here, who works with Vassallo on that book there. Constantin Mail here for scalar wave effects. Modernese. Joe Papp here. Preparata. We've got Harold Puthoff here and Eric Davis here on extracting energy from the quantum vacuum. Harold Puthoff here and Prystrup. Ken Shoulders, Christopher P. Tinsley. Yeah. So a lot of characters we know here. There's several conjectures in here. Coherent clusters. This whole zeta B1 gang frequency. This is straight out of the Occam's razor book. Entropy, and so they're talking here about changing the entropy here, and effectively it's talking about making a condensate. And so yeah, it is about a new phase of matter. So there we go. I think I'm ready to say that if what Mako has put out today is true, and there's one other interesting thing that Rossi was talking about. He made this thing very, very heavy, and he said it had a lot of iron in there. And we found, I recommended to people that are doing replications of Vega experiments, you need the iron in there because it's magnetic. And if you have charged EVOs, at least they can get trapped by the magnetics. If they're not charged, then they don't necessarily get trapped by that. But he called it a countermass. And I thought that was a really weird phrase. And I thought, well, maybe it's just his Italian. But I thought, no, if he's got one of these kind of spherical things going on and it's producing some kind of propulsion, you would call it a countermass, wouldn't you? Because you would be trying to stop it from flying away, maybe, if it got to that point. So I wonder if you got the ECAT SK and you just moved it onto its side, you're depending on which way, your car would either go faster or slower, because it wouldn't be lifting the working against the countermass, but it would at least be either working against the motion of the car forward or backwards. So there's that. It makes more sense to call it countermass in that instance, unless it's extracting energy from the iron in the same way that paper from 1992 from the Russians talking about the flight to Alpha Centauri is doing. Is actually extracting some chi, some hidden energy within the matter. Maybe it's doing that. So it's either shielding or it's anti-gravity, or it's providing energy from the iron mass, which, would last for a very long time, and maybe replaced by the environment anyway. But I would imagine it's something like that. And so I am probably about 80% sure that Rossi actually has something now. And I think it's surprisingly simple. And it may be a combination of destroying matter and releasing energy from that in the phase singularity, or straight capture of energy from the vacuum, because he talks about vacuum polarization in his paper. But there is no doubt in my mind that it will be a fractal toroidal moment-based system, because he refers to Ken Shoulders, he refers to Hal Puthoff, he refers to the Aharonov bomb effect. We know the Aharonov bomb effect occurs in the center of these toroidal structures. That's where it occurs. And so it must be this. And if that's the case, then he will have strange radiation. He will have emissions, and the ion will stop the ion will stop the ones that are in a charged state, but they will not stop the neutral ones. And they will potentially cause harm. And so, Rossi, or a collaborator of Rossi, if you are watching this, inside your ion shielding, you need to place some silver foil, or the thinnest silver sheet. It doesn't need to be thick. And the point of the silver is to do what it was doing in the real-time X-ray tubes of Nikola Tesla with his etheric matter rays. It is to do what was observed by what's his name? Russ George, when he had a corona discharge. I mean, you've literally got Carrere's papers in your references. So he was doing a corona discharge and with deuterium, and he had palladium doing corona discharge, and he found that when he put different metals in front of the Geiger-Muller tube, which was not recording any counts, the counts went up, but when he put in silver, that was by far the highest. And this is the basis for the Shishkin shielding technology, which you could choose to paint on the outside of the device. So for the love of God and for your own health and safety and anyone else using this device, please put some silver inside the prior to the shielding to convert any neutral exotic vacuum objects, preferably in a passive way, into white EVOs that will then either interact directly with the silver or interact magnetically with the iron and dissipate themselves in there. And ideally, you would put the shielding as proposed by Shishkin. And if you want to find out how to do that, you can go to the translation that's on my blog at remoteview.icu. Andrea Rossi, I wish you every success. Please get this out there as soon as possible. For those people that are out there, I think you can see where this is going. And then the question arises, what do we do as a species with infinite energy and the ability to travel almost instantly, almost anywhere, or extremely fast speeds to very great distances? What do we do as a species? Yes, I've argued in recent weeks that no, we don't need to worry about the end of the world because of pollution, because this will enable us to clean the pollution up. I've known since 2017 that these technologies have already been weaponized in multiple jurisdictions. And so there are people, you know, if the end of the world is inevitable, either through use of these weapons in war or use of nuclear weapons in war, then that's inevitable. So we already know that's inevitable. So come on, why don't we have these technologies to alleviate the poverty around the world? My second word on this presentation today was ODE, infinite potential and disruptive. Okay? There's nothing more disruptive about this. And since I moved, I mean, knowing how something can be done is different from knowing it has been done. And I know it had been done in the military space, but basically it's been done, and it's not complicated. And so we are at a point now where things will move very, very, very quickly. And for the last couple of days, even before this data came from Mako, I was feeling physically sick. And I almost couldn't sleep for days. It wasn't quite as bad as my initial realization, the fact that why had I even been bothering to do any of this? Because in 2017, I realized that in late February 2017, I realized that this had already been discovered. And the reason for a lot of the problems that people have had in the field is because they've been misdirected or had their careers destroyed or ignored through the propaganda, military industrial complex, whatever it is. Everything has been thrown to tell you that ball lightning is not the solution, and what constitutes ball lightning is not the solution. But what I've shown you today, that at Edwards Air Force Base, they are specifically calling these things the same thing, and it goes all the way back to Bostic and definitely back to Tesla. It is the same thing. This is the tool. This is the thing that does it. It is for the propulsion directorate. Like they're not doing it for the energy directorate. They're doing it for the propulsion directorate. It is a means of propulsion, right? So it is both propulsion and unlimited energy. And with those two things, this is possibly the most disruptive time in the modern cycle of humanity on this particular planet. And we will effectively have infinite potential, both to realize our dreams in the heavens, but also make an incredible world down here. But the disruption is just going to be absolutely ridiculous. So with that, I'm going to have a look at your questions and see if I can answer them. So if you have any questions, I don't know. I haven't been looking at any of the chat. I just wanted to get through what I wanted to get through today. And I hope it's been interesting. So thank you again to Gary Johnson. Very much appreciated, £20. And thank you again. HR says, Bob, can you please share the link to this paper again? Yes, I will put the link in, with all my notes in it in the blog. You can actually look for it. I think it's already in my blog somewhere, but I can't remember. And then Vanilla Isis says, you're going to need many coffees if you continue to receive papers like the one shown today. I think the papers that I've shown today really wrap up that this is exactly what it is. And we are in the process of receiving unlimited energy. And we, as a species, need to come to terms with that. You know, there's all kinds of plays that you can make off that. You know, those people that have the funds to short things. And this is not investment advice, but what would you do if you knew this was occurring? Don't take my word for it. Maybe I'm wrong. I'm often wrong. Oh, thank you, Laszlo. That's wow, that's amazing. Yeah, this is the answer, and it's actually been the answer. Tesla definitely discovered this and rediscovered this. And I'm absolutely certain that we'll find out that things in the ancient world were done with this as well. Nick Knox says, Bob, can you explain why more condensed forms of matter release greater amounts of energy? How is this tied into the vibrations in the vacuum? Essentially, when you... it's like the Casimir effect. If you take two metal plates, there's some electromagnetic waves that can still oscillate between them, and they're not outside of it, outside of the system. And when you push them together, those waves have to be released. The energy has to be released. So if you can imagine that most matter is an anapole, like an anapole is a special form of a toroidal moment. an anapole has a non-radiating boundary and it has its own space-time inside. So an electron, a proton, and a neutron are all anapole structures, or toroidal moment-bearing structures. And if you make those more dense, the space-time inside, which is different, and is basically pushing those matter, those vacuum fluctuations and energy out. When you condense the matter further, they are then able to be released. You've kind of like given them a place to go, a place where the flux can go. It's in Stoyan-Sargachev's Basic Structures of Matter Supergravitational Theory. Don't ask me where. I haven't looked at it for years. It's not a small book. Yeah, he gave this to me on December the 6th, 2014. There we go. There we go. And I used this first in my Manipulating Matter presentation to my Copenhagen lecture in 2017. Let me see if I can see it here. It's somewhere in here. Maybe in my Copenhagen presentation I have a link to the actual reference. Anyway, it made sense to me back then. Sometimes I don't like to rethink too much. Oh, thank you very much, Laura. That's awesome. Wonderful. What is the name of that book? It's called Basic Structures of Matter Supergravitational Unified Theory by Stoyan-Sargachev, Sarg for short. He actually was one of the few people that's replicated the Hutchison effect, and he's also he did a propulsion device which actually has a electric field and produces a toroidal structure around it. Hi, Malcolm. Thank you for all your work and support. Bob, what about 6 different glass globes arranged in a circle? Do they all need to be... Ken, that's actually not a bad idea. Yeah, that's not a bad idea. It's funny you should say that, because I'm doing something in Canada, but I hope to live stream that. So whatever happens, you will see it. It's not too far removed from what you've just said. So, would cavitated water be safe and healthy to drink after discharge? Well, what are you using to discharge into it? If, you know, I wouldn't like a lot of nickel in my diet, and I wouldn't like a lot of tungsten in my diet. So, you know, what are your in Canada? You say yes. You know where you used to live, David, not where you do live, but maybe you would like to fly over. Oh, and by the way, actually. Now David is on the line here. I have a sample here from one Griffin's Labs, and this is from an etheric matter ray generator. And we will be looking at this here. This is the impact. In fact, I'm gonna put it on the other camera. Let me put that on the other camera here. Then we can see it a little bit better, I think. Let me go there. No. There. Okay, let me put it here. You see that better? No. There. That is the target from an etheric matter generator. That is the back side of the target. That hasn't been hit so many times. But we will have a look in detail at both sides of this target, and we'll see if because it's in a atmosphere which should have almost no elements in it. This is basically aluminium, not the best aluminium. It might have a bit of magnesium and silicon in there, but other than that, there's just bunched electron torus evos striking that, and I'd be interested to see what we see there. I expect we'll have some calcium in the center there, in which case we'll have proved conclusively transmutation in that device. Oh, you can't see the other camera. I'm such an idiot. Let me show you. Sorry. Let's try. There we go. This is the target. And you can see on the other side where it just got hit a few times by the gun. Some manipulation in the aluminium there. But on this side, I think we're going to see a selection of elements in there, because aluminium oxide, as you know, is white. It's not black and red. So I think we're going to see some different elements. And if we do, then we'll have proved that Tesla was actually almost certainly transmuting elements way back in the 1880s. Oh, the back is where tungsten wire was welded on. Okay, so that's interesting. I don't think 6 magnets will do anything. You need the electrodynamics of the plasma and its toroidal moment. So yeah, I mean, from my point of view, let's fire this up again. Why not? Kind of like it like that, and I can twist it round any way I like. We'll bring the magnet in there because I liked separating out those. Anyway, we'll leave that there. Let it dance there for a bit. You gonna dance? Why don't you dance for me? Dance. Okay. I'll change the angle here so we can maybe get a better look at it. Now, then try that. Yeah, except my mugshot is in the way now. Yeah. Okay. Ooh, vase, yes. We'll put the vase in the background there, shall we? There we go. Thank you to Matt Bell. Oh, seems to like the vase now. Ah, sorry, Matt. There we go. Way better than lava lamp, yeah. Although if I was actually making this so it had the tori subtori in there, I probably wouldn't want to be anywhere near it. I think it would be very dangerous from a chi point of view and from a consciousness point of view. So do bear that in mind. Please play safe. Pretty stable there right now, isn't it? Ooh. Yeah. And off and on. It's actually more purple to the eye than the camera's. Maybe I can adjust the camera and get it to look like it actually looks. Sorry. Don't know. Not like that. I've changed the shutter and the exposure now, so it's going to look very different. Where are we? If I can actually get it up. Come on. Play nice. There we go. Very, very different shutter now. Cosmic edge shape there. Yeah, that'll be nice. Cool. That's closer to the color. It's a little bit too dark, but as you can see, you can probably fiddle around with it forever. Have you played it some music? No, or maybe I can sing at it. Round like a circle in a spiral, like a wheel within a wheel. No, it doesn't care. It doesn't care at all. Try a flat magnet near it. I've got a ring magnet. Have I got a flat magnet? I've got some little neodymium cube magnets. I can put a whole ring of them. Here we go. Of course, they're all facing different directions, so I don't know whether this is going to be any good. Quite a lot of these. What do you think of this, guys? Oh, it didn't like that at all. Didn't like that at all. Okay, all right. What are you going to do? Yeah, look, doesn't like that. Wow. Oh, no. I don't know. Lots of these. What are they doing? Nothing. They did something a little while ago. It depends. When it's really running really low power, it doesn't seem to want to respond to the magnet much. I mean, it is just, but if it's running at higher power, it responds quite a lot to the magnet. Like there, a lot when it's making a lot of noise. But yeah, when it gets quite stable, it doesn't really care about the magnet. Little substructures forming there with them moving. Yeah. I've got some phasing going on there. Oh, didn't like that at all. Yes. Hit it with a laser. Let's do that. Yeah, I've got lasers. What do you want? Blue laser? Blue laser? Green laser? Here we go. What do we got here? Let's see what we got there. Oh, here we go. Purple laser. Try not to break anything. This is the... Oh, don't want to get that in my eye. Well, it is producing a little bit of a beam down from the laser. Kind of grows out from it. Okay. Let's try a different laser. I don't like the way that thing makes my hands feel when I'm near it, by the way. Just letting you know. I'm not so sure it isn't producing a toroidal moment when it's got those little substructures. And in that which case, I really don't want my body or flesh near it. My hand feels a little bit weird. What have I got here? There we go, a red laser. Let's get it stable and see if we can take it from stability. Okay, so it's nice and stable there. And introduce a little bit of a red laser. Oh, hello. Put the red laser on there. Can I get it to go through? I think I just store it doing a... No. Yeah. Okay, so if I put it at an edge here, look, I'm getting it to separate there. Not separated. I've got to do it at a distance. Yeah, it's the laser that's doing it. Come on. Come on. Speeding up now. Speeding up. Speeding up. Whoa, turn yourself off. That globe is actually getting quite hot now. Ah! Jesus, hell. Whoa. Okay, that is not cool anymore. Oh dear, I should get the thermal imaging camera out now. Ow, 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 ow. Yikes. That got very, very hot. Very, very hot indeed. Jeez. All right. There, add red laser at an angle. I'm going to do it now. Well, I don't want to look at it. That's my camera moving. No. I'm trying to do is get it at an angle on the... There we go. And what I'm trying to do is get the laser to go through the torus. And as I do that, it starts to spin up. Spins up, spins up. turn it off and it goes away. Is that just my hand? Let me bring my hand in. It might just be my hand. Maybe I've got some static build up on my hand. Or maybe it's, no, it's got very hot again. Okay. Well, it kind of gets very hot. It's really hot now. Anyway, lots of fun games there. We could play all night. Thank you, Mark Alexander. That's really kind of you. For bandages, thank you. Yeah. Yeah, probably blow up with hot air. That's true. Yeah. Yeah. Maybe play safe on these things. Yes, I've turned it off now. You can look at my mugshot here. We'll go back to the cover art. There we go. Does the laser heat it? No, the laser's pretty cold. It's very low wattage. Yeah. The first and the second time. Oh, I don't know what the shutter speed is. Let me see if I can find that out. What do I have the shutter? I have the shutter speed to 1/80th of a second and ISO 100. I can turn it on and just show you. In fact, I can show you the interface for the camera here, and then we can yeah, if I can. Let me see. It's going to allow me to do that. Where's it gone? Okay, there we go. Okay, why does it like to live on that screen? It doesn't want to move up to the other screen. That's weird. Give me a second. No, that's not allowing me to do that. Okay. Right, so, well, this is going to be a bit tedious. Oh, no, I can do it like this. Let me do it like this. I can honestly say my hand feels a bit weak now. I don't know whether that's holding something above it, but it really feels weak. So just the warning, guys. Yeah. Ah, there. Okay. I should be able to adjust this and you see it at the same time now. Right, so I'm going to turn it on. Okay. So this is at ISO 100 and I'm going to go to 125, 200. Thank you very much, Claire Westwood. Yeah. Okay, so it's clipping there. You can see it's clipping. This is just clipping, so that's no good. So, and it's gone out of dynamic range there. I'm going to change. This is the shutter speed is 1/8000th of a second, and I'll move the ISO up. Right, so you can get a nice look into the plasma there. That's a ISO 3200, and shutter is at 1/8000th of a second. I'm just moving it around with my hand. So I will change the ISO down. That's 2000. That's 1600. That's 800. Yeah, it's not a lot to see there. So I'm going to move the shutter up to the next. This is 1/64 thousandths. Okay, and then we go to 1/5 thousandths. And this is 1250 ISO, 800 ISO, 400 ISO. I'll leave it on. I'm going to leave it on 1000 ISO, and I'm going to move the shutter up here. This is at 1/3200ths. This is 1 1/600ths, 1,006 of a second. This is on 1/1000th of a second. That's 1/500th of a second. 1/400th of a second. So you can see some of the pinch. It's definitely pinching when it's like this, and it's definitely less responsive to a magnet. I'm going to bring this ND52, this huge magnet in. It is responding a bit there. It's moving away from it in this case. Whoop! Okay. It became unstable. It collapsed and then became unstable. Okay, that's the wrong color. At the moment, it's slightly purple to the eye, and in this ISO, it's reading out as bluish. So I'm going to turn that up and change the shutter down. Yeah, you can definitely see there's a core in there, a pinch core. I'm going to turn the magnet around the other way and see what happens. Now it's separating out. It's a shame you can't see that very well. I think I'll turn the shutter speed that way and turn the ISO down. So that's 1/160th of a second. Okay, I'm going to turn that off, let it cool down. Yeah, it's not hot. Now it's not hot compared to what it was before when I was firing the laser in it. Interesting. Okay. Enough of that. Right, so let's do a quick review. This was O'Day, Infinite Potential. And this pretty young AI lady here. I don't want her to be suffering exotic vacuum object strikes and chi removal from her body. I would like the correct shielding in place as this technology is put into use. Whether it's in the form of propulsion device or whether it's in the form of an energy generator, pulling energy from the vacuum and or from fusion, fission, or otherwise matter manipulation, including baryon decay. We looked at this paper, a short letter rather, from Richard Feynman apologizing to Kenneth Radford Shoulders, January the 31st, 1986, where he apologized for throwing him out of his way and said that he can understand how these things can hold together. We had a look at a device. I showed how this was a topological monopole and a better model than that in the famed discovery of a topological monopole in condensate, and how that is a model of ball lightning. And in this microwave model of ball lightning, again, the non-radiating boundary and the fractal torus Tor that will be producing a magnetic loop, which is itself producing a toroidal moment, has a field energy density that peaks in the core. And this is where the phase singularity is. And being a 4-Tor structure, it would actually look like this rather than this 2-Tor structure. And we have simulated that here and seen it in the work of the Vega reactors and in the Neil Crichton Gold. And then we looked through a very, very important paper rather. Here, if we go up to the top, and it was from Edwards Air Force Base, Propulsion Directorate, Phillips Laboratory, and University of Dayton Research Institute. And we saw that it effectively has a closed Poynting vector inside the sphere, and that could lead to non-radiating energy and the aggregation of energy within there, that these are the same things as ball lightning and fireballs, that there could possibly be some 0 point energy being caught, that Bostic was a reference, Kapitsa was a reference. It's effectively a spherical torus, and you've got various forms of it depending on parameters. It has a non-radiating boundary. The force-free plasmoid is above a critical frequency, and a vortical motion stabilizes that plasmoid. It is a superfluid in parts, potential for capturing Casimir and 0 point. It has what they call a vacuum current. They actually call this a vacuum plasmoid, where they might be quite difficult to detect. Self-sustaining ball lightning, there is a change in the vacuum permittivity resulting in superluminal properties internally, and that could explain some of the strange things that go on in these things. And that it can store, you can pump the plasmoid. Here's a method for making the plasmoid, and you can store energy in there, and the energy amount stored in there in a 10 micrometer device, a plasmoid, was ballpark the same as that which lit the Neil Crichton Gold light bulb in his Lion 1 reactor. So his observations, given honestly, alongside with the observations he didn't know at the time, he didn't know that his reactor had cooled at such a fantastic rate. It was in the data, but I said it must have done. And then the people that had the data on the memory card reported to me, why are you saying it's cooling down? I said, well, because basically it looks like it's splat cooled. And it's got no crystals in there. It's just an all amorphous blob. And they said, well, this data shows that it cooled at like 1,000 degrees a second. So, and there we go. And so it's all consistent with these condensed electrons that have had to release photons, possibly in the form of UV rather than thermal photons, has to gain back photons, but really the only ones that are available to them are thermal photons in order to get the kinetic energy back up as they become normal electrons. And so that would account for the lighting of the light bulb and the other observations there. Non-radiating boundaries, Bostic and Puthoff and Shoulders mentioned, Kapitsa mentioned, and so forth. So that was that. We talked about this one. We talked about how the structures can break up, and that when they break up, if they become unstable, they produce these beams. And I showed that we had, in fact, done such a thing somewhere. I had done that. Go and find that. I think it was here. Not there. Not there. Well, anyway, I showed you in one of the blogs that I had achieved that, and Henk Duren and David Boutelier had achieved that, and we talked about how David Roth said that ball lightning of a certain few millimeters would be able to provide all the energy for a house, and that was about it. Then we described how a ball lightning could or this technology basically could provide propulsion, and that you would need to create this toroidal structure around, magnetic structure around, in order to create the toroid going around the device, and that the alternative is to create it in a sphere with your phasing capacitor arrays. Once you've got your plasma in there, to create your torus in there, and that would create the gravitational azimuth, and then you could direct that and join the beams, cross the beams, or do whatever it was that you would want to propel your device in various ways, like with the TR3B, if that's what that device was doing. So I think that's about it, really. Propulsion, energy generation, and all of the terms that we've been using validated by the Edwards Air Force Base paper. So I'm going to have a quick look to see if there's anything else you said, and if not, I'm going to call it at night because it's 1 o'clock here. I have to say that actually I just want people to know that today was the most we've ever had on a live stream. I think there was over 200 for the first time in the history of this particular blog. I think it reached something like 225 at one point. So thank you very much for all those that participated tonight. And thank you very much to all those that gave super chats. Thanks again to Claire Westwood, Mark Alexander, Laura, Laszlo, Pap, Vanilla Isis, HR, and Gary Johnson. We are at the new dawn of an old age, and unlimited energy and propulsion technology. It's just it's going to be a shock, an ontological shock, and it's coming. David, if you want to come over and join us, let me know. Thank you very much. My name is Bob Greenyer. This was Ode Infinite Potential. Buenas noches, dobro noc. Good night.